Hello everyone. What we'd like to do in this video here is learn how to solve log equations. In the last video, we learned how to solve exponential equations. Now it's time to solve log equations. So there's a general strategy that we'll always kind of follow when solving log equations. Kind of similar to when we're solving exponential equations, we usually want to try to isolate the exponential equation. So here we're going to try to isolate I'm going to say logs on one side. Okay, and I'm going to kind of note here, may need to use log rules. May need to use log rules. Okay, what else do we need to know how to do? From here, we're going to want to write in exponential form. Write in exponential form. Okay. 3, we are going to solve for the variable. Solve for the variable. And 4, we need to be very careful when solving logarithms because logarithms have specific domain restrictions, so you're always going to want to check your answer. You're always going to want to check your answer here. Okay, let's do some examples. Okay, so our first example is, let's say we want to solve, how about 4 plus 3 times the log of 2x is equal to 16. Okay, maybe go ahead and pause the video and try this on your own before we do it together. Okay, let's do it. First thing we need to do is we want to try to isolate the logarithm. So let's go ahead and subtract 4 from both sides. So here we'll get that 3 times the log of 2x will be equal to 16 minus 4 will be 12. From here, we could divide both sides by 3. Divide both sides by 3, so these 3's will cancel. Okay, so we'll get that log of 2x is equal to 4. And now we're going to switch into exponential form. So this is log base 10. This is log base 10 since there's no base there, it's just log, it's base 10. So this is the same thing as 10 to the 4th. 10 to the 4th is equal to 2x. So we have that x is going to be equal to 10 to the 4th over 2. What's 10 to the 4th? Well, that's, what, a 1 with 4 zeros? All over 2. So we have that x is going to be equal to what? 5,000. And here is our solution. Okay, we might want to be a little bit careful in general. We need to check this. Mainly, we just need to make sure that when we plug our answer back in, we're not getting a domain problem. So if I plug x back in, I'm going to get 2 times 5,000. That's 10,000. You can take the log of 10,000. I'm mainly just checking when I plug the number back in. I want to make sure that what's inside of the log doesn't turn out to be negative or 0. This will work out fine. Okay, let's do another example. So again, when you're checking your answer, you really just need to make sure you're not getting sort of domain issue with the log. Plugging in 5,000, I'm going to have no issue with taking the log of 10,000. If it was negative, if it turned out to be negative on the inside, you'd be worried. Okay. We're going to have that in this next example. Let's say that we want to solve, let's say, log of x plus 2 plus log of x minus 1 equal to 1. So we want to solve this here. Go ahead and pause the video and maybe try this on your own before we do it together. Okay, let's do it. The first thing we need to do is we need to have the logs isolated on one side, but we want just to have one logarithm on one side. So the first thing we're going to do here is we need to combine these logs. We can use the log rule, I think it was log rule 1, where when we add logs with common bases, we can multiply their arguments. So this is equivalent to log of, this will be what? X plus 2 times x minus 1 will be equal to 1. So we just use log rule 1 to take 2 logs and make it just 1 log. Okay. Next step is we want to write this in exponential form. So this is log base 10. So this is the same thing as 10 to the first power is equal to x plus 2 times x minus 1. We switched into exponential form. Okay, so 10 to the first power, I hope we believe is the same thing as just 10. So now we're left with a quadratic that we need to solve. So we want to try and solve this. Well, when we have a quadratic that we need to solve, we want to make sure we have all the pieces on one side. I need to FOIL this out. So we're going to have 10. What are we going to get? X squared. We'll get x squared minus x plus 2x minus 2. So we'll have 10 is equal to x squared. What will that be? Plus x minus 2. So let's go ahead and subtract 10 from both sides. So we'll get that 0. We'll get that 0 is equal to x squared plus x minus 12. Okay. We can solve this. You could use the quadratic formula if you'd like. Sometimes you might need to. But I think we can factor this problem. I think this will factor to what? I think it's going to be x plus 4 times x minus 3. So I hope you believe that this is screaming at us that x could be negative 4 or x could be 3. Now, be careful. Do not just freely, do not just box these in. There could be a domain problem with the logarithm. Notice that we need to check these. So for example, let's plug in 3. Does that one work? Well, if we do log, plugging in 3, well, we get 3 plus 2. I'm going to kind of plus. Wish I had more room. I'm always saying that. I always need more room. 3 minus 1 is equal to 1. Okay. Well, what is this? This is the same thing as what? Log base 10 of 5. Log base 10 of 5 plus log base 10 of 2 is equal to 1. I already know this is going to work. I'm not going to have a domain issue when I'm plugging in 3. You can continue just to make sure you have the right answer. Okay, well, log base 10 of 5 plus log base 10 of 2, we could use that exponent rule to multiply those together. So this is the log base 10 of 5 times 2, which is 10. Does that equal 1? Yeah, well, 10 to the power of 1 equals 10. This is a correct statement. So this one works here. Notice that we are going to have a problem, though. This is a good answer. We will have a problem with x being negative 4. Notice if we try to plug in negative 4, we're going to have a domain issue. If we plug in negative 4 here, negative 4 and negative 4, notice here, this is the log of negative 2, this is the log of negative 5. There's a domain issue. We can't take the logs of negatives, so x cannot be equal to negative 4. So we only have one solution, x being 3. So we always have to check our answers. Okay, let's go ahead and try this next example. Go ahead and pause the video and give it a shot on your own before we do it together. Okay, there are 2 ways we could solve this problem. Okay, the first way is we could just try to isolate the logs on one side. So one approach will be saying log base 5 of x squared plus x minus log base 5 of 20 is equal to 0. Okay, we want to have the left-hand side just be in terms of a single log. So we can use what, log rule 2 I think it was, and we can divide their arguments. So this is the same thing as log base 5 of, what will we get? X squared plus x all over 20 will be equal to 0. From here, we could write this in exponential form. So this would be the same thing as 5 to the 0 will be equal to x squared plus x all over 20. 5 to the 0 is the same thing as 1. So we have 1 will be equal to x squared plus x all over 20. Okay, this is a quadratic equation. We want everything on one side. But this also has fractions in it. And whenever I see an equation that has fractions in it, man, let's clear those. Let's clear those fractions. So this will be the same thing as 20 being equal to x squared being equal to x squared plus x. These will cancel. Okay, we could subtract 20 from both sides, so we'll get 0 is equal to x squared plus x minus 20. Okay. In this case, let's see, what can we do here? We can factor. You could try to use a quadratic equation, but I'm going to avoid that if I can. Okay, so let's see. This will factor to, I need what, a 5 and a 4. And they add to a positive, so the smaller has to be negative. So, this is saying that x could be equal to negative 5, or x could be equal to 4. Okay, now we got to think of these solutions work here. Okay, we just got to make sure there's not a domain issue. Okay, if we plug in negative 5, what we're going to get in, we're going to get what? We're going to get a negative 5 squared plus a negative 5, and this is all inside of a log base 5. Okay, well, this is log base 5. What is this? This is 25 minus 5. This is 20. Log base 5 of 20. This solution here is going to work. So this is a good solution. Okay, what about 4? Well, if we have a 4 here instead, we have a 4 here instead. Okay, 4 squared is what, 16? 4 squared is 16 plus 4. It's not a negative number. Log base 5 of 20. So it's going to work. Okay, in this case, both of these solutions are good. Okay, for this particular problem, I wouldn't say that this is the slickest way to solve this one. Notice here that in this case, because they're both log base 5, we didn't actually have to move them both to one side of the equation. In this case, it's almost like we're kind of dropping the base, but in terms of logarithms. So if I have a log base 5 of something is equal to log base 5 of something else, well, it kind of seems reasonable that what's inside of them should be equal to one another. Okay, yeah, that'll be true. You could also think that we could apply the inverse function to both sides. So the inverse of log base 5 is a 5 to the x. So we could exponentiate both sides to the power of 5. So I'm kind of undoing the log by exponentiating both sides with a base of 5. These cancel each other out. They're inverses. So this just goes down to saying that x squared plus x will need to be equal to 20, which is where we are right here in the problem. So for this specific problem, you could almost just kind of cancel out the log base 5s right from the beginning, and it would have been actually a slicker solution for this one here. But be careful, you can't always do this. Let's see another example. Okay. Let's say that we have log base 5 of x plus log base 5 of how about x plus 1 is equal to log base 5 of 20. So what I'm trying to do here for this example is actually very similar to the last example. So I just kind of want to make a note here with this one. For this specific problem right here, just because they all have log base 5s, we cannot say that this is the same thing as x plus 1 is equal to 20. This is not true. We can't just cancel them all out here, mainly because of the addition. So just be a little bit careful here. We can't just cancel those out. We have to use a log rule for this one. We'd have to realize I have to multiply these together, or in this case, since they also have a base of 5, I can do log base 5 of x times x plus 1. So here, log base 5 of x times x plus 1 will be equal to log base 5 of 20. And now since I have a log base 5 on one side, a log base 5 on one side, they're both isolated, then we can say this is x times x plus 1 is equal to 20. Or this is x squared plus x equals 20. X squared plus x minus 20 equals 0. This is the same problem we just did a second ago. X plus 5, x minus 4 equals 0. X could be negative 5 or x could be 4. So I just want to make a note for this problem here that be careful, we just can't cancel across because of this addition. You would need to combine the logs first before you cancel. Okay. Okay, let's try log base 2 of x plus log base 2 of x minus 2 is equal to 3. Go ahead and pause the video and give this one here a shot. Okay, let's do it. First thing we need to do here is we need to combine these logs. This is log base 2 of x times x minus 2 is equal to 3. In this case, we could switch into exponential form, which would be the same thing as like me exponentiating both sides with a base of 2. Or we could just say this is equivalent to 2 cubed equaling x times x minus 2. I'm switching to exponential form, which would be the same thing if we kind of exponentiate both sides with a base of 2. Okay, so what is 2 cubed? 2 cubed is 8, so this is 8 will be equal to x squared minus 2x. Subtract 8 from both sides. X squared minus 2x minus 8. 0 will be equal to, let's see, how will this factor? X, well, I think I need combinations of 4 and 2. They have to add to a negative, so the bigger one has to be negative. So here we could have that x could be 4 or x could be equal to negative 2. Okay, let's see if both these answers work here. Okay, 4, this will work. If I try to plug in 4, I'm not going to get a domain issue. This will be okay. I will get a domain issue with x being negative 2. Log base 2 of negative 2, you can't take a log of a negative. So x equals negative 2 is not a good solution. Only x equals 4 will work. And for fun, I mean, we could plug this in and chug through it for fun. Why not? Log base 2 of 4. Log base 2 of 4. Log base 2 of 4 plus log base 2 of 4 minus 2. So I'm plugging 4 in. Okay. So what is log base 2 of 4? 2 to what power gives you 4? I hope you believe that this is 2. Plus, what's inside here? 4 minus 2 is 2. What's log base 2 of 2? 2 to what power gives you 2? I hope you see it's 1. 2 plus 1 is 3. Ha! Works. Okay, let's do another one. Okay, what if we have, let's say log base 3 of x plus 15 minus, how about log base 3 of x minus 1 is equal to 2. Okay, go ahead and pause the video and give this one a shot on your own. Okay, let's do it. First thing we're going to do here is we're going to notice that I have a log base 3. We're subtracting, so I think log rule 2 says I can divide the arguments. So this is log base 3 of, we'll get an x plus 15 all over x minus 1 will be equal to 2. Okay, we could switch forms now, or you could exponentiate both sides with a base of 3. kind of applying the inverse function to log base 3. The inverse of log base 3 is 3 to the x. So this would be the same thing as, these would cancel. This would be x plus 15 all over x minus 1 will be equal to what? 3 squared. It's the same thing as me switching forms. 3 to the power of 2 is equal to the inside. 3 to the power of 2 is equal to the inside. Okay, 3 squared is 9. So how about I put a 9 here? Okay, now I got to solve this equation. It's an equation that involves fractions. What are we going to do? We're going to clear the fractions. Anytime you see an equation that has fractions, clear them. Clear them. So we have that x plus 15 will be equal to, let's go ahead and distribute this 9 in. So I'll get a 9x minus 9. Now we have a nice linear equation to solve. How about we subtract x from both sides, and also we can add 9 to both sides. So what would we get here? We're going to get, what, 8x. We're going to get, maybe I'll write it over here. We're going to get 8x. 8x is going to be equal to 15. 15 plus 9. 15 plus 9, what is that, 24? 24. Divide both sides by 8. We'll get that x. We'll get that x is equal to 3. So we only got one solution. We still need to check it. If we plug this in, what are we going to get? Log base 3, 3 and 15, what is that, 18? Hopefully you can see it's going to work, because I'm not going to have a domain issue. Minus log base 3, what's 3 minus 1? 3 minus 1 is 2. Okay, does that equal to 2? Should. Well, again, it's kind of hard for me to 3 to what power? 3 to what power gives you 18? I don't know. 3 to what power gives you 2? I don't know. Well, let's use log rules here. This is the same thing as saying log base 3 of 18 over 2. This is log base 3 of 9. 3 to what power? 3 to what power gives you 9? 2. Smiley face. Smiley face. Cool. Awesome. So those are all the examples I have for you for solving logarithmic equations. We're done with solving log equations. We're done with solving exponentials. We'll see you in the next video. I think the next thing we're going to start talking about, we're going to kind of jump gears and we're going to start talking about conic sections. We'll see you there. Take care.